Okay, we're going to start section 4.3, mixed and entire radicals. So this is going to be brand new. Okay, we talked a little bit about what a radical is, but now we're going to talk about two different types of radicals that we're going to encounter in the rest of this unit. So mixed radical, kind of just like remember when we had mixed fractions, has a whole number, and then it's also got a fraction. So a mixed radical is sort of the same idea. We might have something that looks like this, 4 root 2. That would be an example of a mixed radical. It's got a coefficient or a multiplier out front, and then it's got the radical part of it, index is 2, and the radicand is also 2. Okay, and an entire radical, okay, looks something like this. If we had root 24, the entire radical is underneath the radical sign. So the radicand, there's no coefficient out front. So mixed has a number out in front. We sometimes call this the coefficient. Okay, entire radical, everything's underneath the radical sign. Okay, so we'll come back to that. So we're going to talk about equivalent expressions. So you could set something up that looks like this: square root of 16 times 9. So there's sort of an expression happening under there. So you know the square root of 16 is 4, and you know that the square root of 9 is 3. So the whole answer is 12, because 4 times 3 is 12. Okay, if we were looking for the cube root, we know that 8 is a perfect cube. It's 2. 27 is also a perfect cube. It's 3. So 2 times 3 is 6. And we'll come back to this, okay? So things that I kind of like to do sometimes before we get started, I'm going to show you two different ways to approach these mixed to entire radicals. One of them is going to be knowing your perfect squares and your perfect cubes, but we're going to be getting to fourth roots and fifth roots, and we don't know those numbers necessarily. So we're going to fall back on some prior knowledge, and we're going to be able to do these. Okay, so here we go. So we're going to be able to use this property to simplify square roots and cube roots. So the first thing I'm going to do is I'm just going to write down my perfect squares again up here, just so that I can address them as we're talking about this. So 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Okay, we know those pretty inside and out. 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. Those are our perfect cubes. And those don't necessarily come to us as easily, but you know what? If we think about it, we can get them done. And again, I'm going to show you a different way. All right, so you should be able to take a look at the square root of 24 and immediately identify that this is an irrational number, that there is no two exact factors that you can multiply together to get you 24. So what we're going to do instead is we're going to take a look up here at our perfect squares, and we're going to think, what's the biggest perfect square that we know divides evenly into 24? Okay, and we're never going to use 1 because 1 doesn't change anything. 4 goes in there, and then 9 gets too big, right? Like 9's not going to work, so we know it's going to be 4. So you could set it up like this. We know that it's going to be 4 and 6. 4 times 6 equals 24. So we could get back to square root of 24. Okay, and then you could separate them out if you wanted. This makes more sense to you. Okay, and we know that 4 is a perfect square, so we get 2. And 6 isn't a perfect square, so we just leave it like that. And what we get is, for an answer, this is an entire radical, remember? That's what we called that, an entire radical. And now we've answered it as a mixed radical. 2 root 6, that's how we'd say that. Okay, so this is the coefficient, the index is 2, and we're left with 6. So that's the answer. And we're going to come back to that in a minute. Okay, square root of 99. So think about what perfect square do you know goes into 99? And immediately your eyes should be drawn to 9. So it would look like this. Square root of 9 times the square root of 11. Square root of 9 times the square root of 11. What's the square root of 9? We know that it's perfect square. 3, and what's left over? 11. So now we've gone from an entire radical to a mixed radical. We would say this 3 root 11. Now we can move on to 72. Okay, now 72, 9 goes in there, but is it the biggest one? So that's what I don't like about this, is you always have to make sure that you pick out the biggest one. And indeed, the biggest one is 36, because 36 will go into 72 2 times. Square root of 36 times the square root of 2. I know what the square root of 36 is. It's 6. And I'm left over with root 2. So now we've gone from an entire radical to a mixed radical. Okay, so this is where it gets a little dicey for me, and that's why on the next page I'm going to show you a different way to do this. Cube root of 54. So what's the biggest cube that goes into 54? And it happens to be 27. So we're going to get the cube root of 27 times, and it goes in there twice. So cube root of 27 times the cube root of 2, and the cube root of 27 is 3. What's left over? Cube root of 2. And we have to remember to include that index. Otherwise, it reads cube or 3 square root of 2, and that's not the same answer. Okay, so now we're going to do this next one. Okay, what's the biggest perfect square that goes into 48? Okay, and it happens to be 16. 16 times 3. Okay, what's the square root of 16? 4. So you solve that. Do you know what the square root of 3 is? No, it doesn't work out, so you leave it as 4 root 3. Okay, perfect square that goes into 108 happens to be 36. It goes in there 3 times. What's the square root of 36? 6. What's left over? Cube root 3. So that's our final answer there. Or I'm sorry, just square root of 3. Okay, cube root of 40. I was getting ahead of myself. So now we're looking for the biggest perfect cube that goes into 40. And if you look up here, here's our perfect cubes. 27 is too big. Okay, and if you know your times tables, you know 8 goes in there quite nicely. 8, and that's times 5. What's the cube root of 8? The cube root of 8 is 2. What's left over? 5. And that's our mixed radical. Cube root of 162. And so now, see, this is where I really have to think about things. So I might go up here and I might start like taking a calculator even and start dividing these numbers out. Works out that it's 27. So you're going to write down cube root of 27, and it goes in there 6 times. 27 times 6 is 162. Okay, so now what's the cube root of 27? Well, we know that that answer is 3, because 3 times 3 times 3 is 27. What's left over? Be the cube root of 6. Entire radical, everything's underneath the radical sign, mixed radical. All right, moving on. Okay, list all the perfect squares. So this is just an activity to think about perfect squares and perfect cubes that are factors of each number, and it says don't include 1 because 1 doesn't really work. So perfect squares, if I had them written down again, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. What ones of those go into 18? Well, the only one is 9. What are the perfect squares that divide evenly into 24? Only 4. Perfect squares that go into 48? 4. That's it. And does 16 go in there? Let's think about it. 16 and 3. Yep. 16. Okay. 98. What perfect squares go into 98? Well, 4 doesn't go in there. 27 doesn't go in there. But 49 times 2 is 98. Okay, list all the perfect cubes that go in there to these numbers. 32, okay? The perfect cube that goes into 32 is 8. Biggest perfect cube that goes into 40, also 8. Biggest perfect cube that goes into 54, 27. Biggest perfect cube that goes into 108 is going to be also 27, okay? All right, I'm going to stop here for a minute, and then I'm going to make another video for the bottom part.